The next concept we will discuss is the productive labor yield. So what is that about? Basically, it will be the ratio of direct labor hours devoted to the completion of a project. Devoted the completion of a project to the potential labor hour, to the potential labor hours. And to show you that perspective before we work on this problem 2 here, with the project that show here, as you can see. So for this power plant project with multiple projects that they do for this company, the Beto, for example, and as you can see the relationship between the direct high hours. So it on the horizontal, for example, it ranges from 500,000 hours to 5 million thousand hours. And then the few non-manual hours, basically indirect hours, the people that not directly do the physical unit of work to complete the project, something like receptionists, etc. Not really put the bricks, put the steel on the project, right? Install the equipment, etc. So as you can see, they have relationship here, and that very important because that hour is money. So they have to plan accordingly and based on the historical project that we have here. And then from that we can see the project that they study is the Edwardsport IGCC, which is out of the extrapolation, and because that is a big project, but they can roughly estimate what should be the direct hours and indirect hours. So with that, then because labor is very important, we're talking about the labor productivity index, and they have to measure over time, for example, LPI, cost performance index, schedule performance index, etc., to reflect what we perform over time for the project in here. And this is Duke Energy project for the Edwards IGCC project, one of a kind power plant project. And with that here, let's go back to problem 2 that just demonstrate this concept of productive labor yield. So with the ratio, basically the direct labor hour devoted for the completion of project to the potential labor hours. So here, problem 2, in the construction of a water treatment plant, a potential labor hours will found to be 200,000 labor hours. On this total, the non-productive activity is spread in the 1,000 labor hours was as follow. So we have that. And then holiday, strike, absentees, temporary stoppage, weather, waiting, union activities, indirect labor, cleanup, etc., rework. Determine the productive labor yield after above factor are taken into consideration. So from that, it will be should be very straightforward application. We have a direct labor hours we need to determine to make the ratio direct labor hours, and in that case it will be L minus A minus B minus C minus D. So from that we can have it 200,000 minus 24 100 30 100 1600, 4000, and from that we have the direct hour that devote to complete this work is 189,000 labor hours. So from that we can easily to determine the labor productivity yield, right? The productive labor yield. And that equal to direct labor hour, the ratio, right? 189,000 divided by the total potential hour, 200,000, and it equal to 94.5%. If you time or 0.945. So that is the answer. What does that number say? So basically it say what does that mean in here? It means that 94%, 94.5% of the budget labor time was devoted directly to the work of the facility. So another 5.5% is potential to save if we put more those hours into direct hours. So that the meaning of this productive labor yield. So that we deal with the first M in this today class. Like I said, we will talking about material and machine as well. So first M with the human manpowers, and then we talk about material, and then machine, money we will deal with for the rest of the first portion of our class.